Hey y'all, let's look at solving equations using both substitution and elimination. You remember we've done ones like this. We won't bother to solve this, but how do we do this? We can either, we can use substitution. In other words, we can pull this over here and then use and substitute that in this equation, or we can just kind of like do the little trick where we make the x's the same number or the y's the same number and just add right straight down and then eliminate that way. Either one of those is fine. You're going to come across other equation types, systems of equations. So far we've dealt with ones with x's and y's. Well, guess what? Today we deal with ones with x's, y's, and z's. Yes, okay. Lots of z's. Okay, so let's look at this. Copy down, pause a second. All right, and this, once you've copied this down, we're going to substitute and eliminate to solve these. Now they will always get this; these will always be solvable, so don't worry. So look at we got z's, we got y's, we got x's. We're gonna solve for all three of those variables. Okay. So what they will do, they will give you a nice equation here, or you can take this and go, okay, let's look at this one first. Okay, x is the same thing as 2y. Okay, well if x is the same thing as 2y, we can put the 2y here and we can put it here. And if we do that, we'll have two new equations on the bottom here, right? Okay, so let's put that right there. So 2y, we'll put that like a 2y is there and then a 2y is there. Well, let's say 2y plus y will be 3y, right? And that's going to be plus z equals 9. That's just this equation right here. Okay, if 2y is that, then we have 2y minus 3y. Well, that'll just give us negative y minus 2z equals negative 8. Okay. All right. Now let's eliminate. Which what I would do is just you know what? This looks easier to do. I don't know. It looks easier to piddle with this one here. How about that? Let's just multiply this entire top here by 2, so we get two z's lined up nicely there. So we won't have a 3y anymore. We'll have a 6y. We'll have a 2z, and we'll have an 18. All right. So let's do that. We have a 6y. We have a 2z and we have an 18. All right, so let's just add right on straight down. So 6y plus negative y, 5y. That of course goes away. 18 plus negative 8 is 10, so we have y is equal to 5. Okay, now we can go somewhere. If x is the same thing as 2 times y, then that means x is 10, right? Okay, now we can use any of these to solve for z. So let's just, I don't know, whatever, first one's fine. Okay, so this one hasn't, let's just do the bottom one. How about this one, since we can see the x a little better. So x is 10. Minus 3y, y is 5, so minus 15. Minus 2z equals negative 8. So 10 minus 15 is negative 5. Okay, I think I goofed up somewhere. Hold on a second. X is 10, y is 5. Let me try this again. 2y. Let's try the second equation. See if I have better luck with that one. Okay, so I have an x here, which will give me a 10. All right. Oh, never mind. That's why I goofed up. 5y is 10. Y is 2. That's my bad. Okay. Well, everything goes from there. Okay. So y is 2. So x is equal to 2 times y. I bet some of you guys are already screaming at the screen already a million times. So thanks. I heard you all the way out there. Okay. So here, let's go to this equation here since it's probably the easiest. All right. So x is 4 plus y is 2 plus z is 9. So z is going to be 9 minus 6 or 3. So there we go. Okay. All right, let's try another one. We have better luck this time. Okay, substitution and elimination. Go ahead, and copy this down. Pause it if you need to. Okay, this, once you've paused it, of course, can come back. This is my third equation. I'm just going to go ahead and rewrite this and move the z over, so x is equal to 3z. So I'll write it like that. So there we go. Okay. Well, if x is equal to 3z, then that's what I'm going to stick in there. Okay, so I'll write this equation as 2 times x, or in other words, that'll be 6z, right, plus 2y minus z. So what I can do is I can just go, okay, I'll just do my y's right here. That's going to be a 2y. And then 6z minus z, that'll be 5z. And that equals 12. Okay. The second one, if x is 3z, then 3 times x is going to be 9z. So I'll have a negative y here. And 9z plus 2z is 11z. Okay? All right. So I think what I'll do is I'll just take this bottom equation and multiply everything by 2. How about that? Yeah, that's be like the easiest probably. Okay, so I got negative 2y. My eraser here. I'll get 22 and I'll get 42. Okay, and 42. All right, and we'll just add right on down. 2y plus negative 2y, 0. 5 plus 22, 27. 12 plus 42, 54. So z is equal to 2. Okay. All right, now we got it. X is equal to 3 times z. So we have x is equal to 6. And then we can just take one of these equations. You know, we can just take one of these equations. Easier, there's no x's to mess with, okay? If we know z is 2, let's just do it. 5 times 2 is 10. So 2y plus 10 equals 12. We'll move the 10 over. That's 2y equals 2. So just we have y is equal to 1. And there we go. Okay. All right. Good enough. Okay. Let's look back very quickly at what's called negative vectors. This is really weird. I know this is... Hang with us if you haven't got it 100% yet, but let's look at some oldies here first off. We've got 8.66r, we'll call it, and the u, just don't, you know, those are x and y basically. 2 different ways to name this in polar form. Well, don't forget the hypotenuse length is this, and of course the whole idea is that you are, you know, here's the ship captain you're trying to, or the base you're trying to contact. Captain, we're lost 10 miles at sea. And the first question the captain's going to go is, what direction? Okay. You have to tell him 30 degrees and then 10 miles. So he knows how to sail his ship and to, you know, go rescue you. So, and the way we do this, of course, one way to name this is with a 10 and with our 30 degrees, right? That's what you would tell the captain. 10 miles out and then 30 degrees, you know, wherever you, okay, there's one. Okay, the other way, don't forget, this is going this way, the normal way, the counterclockwise way. The other way to name this is we're going to start here and go counterclockwise. Oh, excuse me, clockwise, my bad. We're going to go in clockwise that way. Okay, to make it to that 30 degrees, you're going to have to go all the way 330 degrees the other way. If you do it that way, clockwise, it'll be called, it's going to call negative 330. That's 2 ways to write it, okay? There are actually 2 other ways to write this as well. So let's talk about that. Okay, here's how. This is kind of weird, but it's called negative magnitudes. But it's, let me just explain to you in the way we're used to kind of talking about. You know, before we talked about the captain of the ship going, okay, where are you? Where are you? And you say, okay, well, I'm 10 miles out. He's like, okay, I know that, but what direction do I go in? It's okay. So he points the ship. You tell him 30 degrees. He goes, okay, I gotcha. Okay. And another way to say that is to go, okay, I'm starting here. I'm 30 degrees here. Another way to say that is that I'm starting here and going negative 330 this way. But I know, never mind, here I come and I'm going this way. All right. My ship is pointing this way for 10 miles at 30 degrees. Oh, there you are. Okay. So you can do, or I'm pointing to, you know, I'm going forward with the ship like that at 30 degrees or negative 330 degrees. The other 2 ways you want to make sure you know is that just imagine the ship. Here's the ship, oops, and let's say it is the ship is still pointing this way. You know what? Let's say the ship is lost all ability to sail forwards. Okay, the captain, I don't know. There's something wrong with the ship. All it will do is go backwards. Okay, it's going to just go backwards like this. Okay, well the captain says, well, I can sail it backwards to you 10 miles, but how in the heck, what direction do I sail this in? Okay, what you're going to do is like this. What you will do is keep extending this line out like this, okay? And the captain tells you, he says, look, I'm pointing the opposite direction, okay? Oh, I can't get you. Okay, you're at this, I can't get there, okay? I'm pointing this way right now. So now what do I need to do? How do I get you? When you go, well, you're going to have to go -10 then, right? Not 10, because if you go 10, you'd go forward. That's not where he is. So you're going to have to call this a -10, right? And then something. What is this something? And of course, you can call it also -10 and then something else, all right? Well, you're going to have to point that ship. Let's say you have the ability to move it around, like to turn it around, but you can't sail forward, okay? So you told the captain, you gotta go backward 10 miles. Okay, backward 10 miles, all right? Which direction? I need to be pointing to get there. Well, you can't tell the captain, you know, turn it 30 degrees, because if you do that, he'll go backwards that way. You can't do that. So you've got to point this captain in the right direction, okay? And here's how you do it. If you know this is 30 degrees, you can't tell, again, you can't tell him 30 degrees and backwards 10, because they'll go, okay, go that way, right? So he's pointing, you know, backwards, all right? We'll just call it that. Okay, you're going to have to get him to go all the way around to this point right there. And then tell him to turn his ship, and then, you know, he can sail backwards. You know, he'll be pointing this way, right? But he'll be sailing backwards that way, all right? The question is, what degree is this right here that we get to where this dotted line is? Well, you know this is a 90. You know that's also a 90, so that's 180. And since these are vertical angles and this is a 30-degree angle, well, this will be a 30-degree angle too. Okay, so you can say to the captain, you need to go all the way around, you know, turn your ship around so it's at 180 plus 30 or 210 degrees, right? Okay. Then you need to, you're right here, then you need to go backwards 10 miles, bam, and there you'll end up right there. That makes sense? Okay. The other way is you could tell the captain, okay, we're starting here again, right? We start at this right there. Well, don't go 210 degrees, just go, you know, with a negative degree, but you need to end up right there so your ship is pointed in this degree, then go backwards, sail backwards for 10 miles. Well, the question is, what is it from here to there? Well, of course, you know this is 90, all right? Well, if we know that this is 30, then that's going to be a 60-degree angle right there. So that'll be 90 plus 60, which will be negative 150 degrees, okay? And those are the two other ways to name that, you know, in the rectangular form and the polar form, all right? And again, you don't, you know, you will, normally you'll tell the captain, turn it 30 degrees and then go 10 miles. And he goes, there you go, forward. But the captain's stuck. All he can do is sail backwards. So you have to take that into account. He says, I'll sail backwards 10 miles. You go, okay, how does he need to point this thing? I'm at 30 degrees. Let me just extend it this way so I can tell him which way to point. Okay, captain, go around 90, go around 90 more, and then go, okay, 30 degrees more to get to this. And the captain goes, hold on, I'm going 90. Okay, I'm going 90 more. That's 180, 30 degrees more. Okay, 210 degrees. Here I come. Beep, beep. I'm sailing backwards. There he goes, going backwards, 210 degrees. The other way to say that, of course, is to just go, okay, I'll point, go this way, go the other way, go negative, and then again, you're pointing to the same place. So you need to go 90, then since that's 30, that'll be 60 as well. So 150, but it'll be a negative 150 to get there. Okay, so let's use that. We're going to add, and of course we can write it like this, and then like this. We can add these two to get a resulting point we'll be at. Okay, I have that slightly wrong. This should be a -4, and we're going to go negative 20 degrees, and this will be 135 degrees. So we'll add these two and see what we get. So first off, let's draw the -4 and the -20. Now, just as a practice, you don't have to be perfect at drawing these. This is just X and Y, get it done, and just draw something approximate. Okay. Normally, we'd say we're going -20 degrees. We're going like this, right? And we'd say, oh, you know, go -20 degrees and then 4. Oh, that would be, oh, look, 4. Here you go. I'll stop right there. I'm going, you know, 20 degrees this way, and then there it is. There's my 4. Okay. But that's not how we want to do this, because this is -4. captain sailed backwards at negative 20 degrees. So don't forget, the captain isn't sailing forward at negative 20 degrees. He is sailing backwards. So instead of being like that, it's going to be going the other direction. He'll be doing like this. He'll be going, let's say this is, negative 20 degrees right here. He will not be going forward this way. He'll be going backward this way, forward. So that's how that'll work, okay? So that's going to be negative 20 degrees, and of course this will be 20 degrees as well. And here you go. And we're going to need to find this R, and we're going to need to find that U. Okay, so there's our 20 degrees, negative 4, and negative 20. All right? Okay, so our question is, again, we're going to use cosine, sine, tangent, and all those kind of things to find out what these are. So let's get our calculator. And then let's find the cosine of 20 degrees. So 20 degrees, and of course, just a reminder, we're going to find R first. To this is the adjacent over the hypotenuse, which is a definition of cosine. So 20 degrees, and then we'll go to trigonometry, and then cosine, which is 0.939, and so on. Okay, so there we go. So, the cosine of 20 degrees is equal to R over 4. We figured out that this was 0.939 or whatever it was, equals R over 4. Okay, so let's just go ahead and multiply that by 4. Oops, there we go. That'll be 3.76, we'll call it. Okay, so this R is going to be 3.76, but don't forget, this is a negative 3.76 R because it's pointing to the left, like in a number line. Okay, now let's go ahead and find the U. And for that, of course, we're going to find the sine. All right, so we have 20 degrees again. And sine is that. And we know we're going to multiply that by 4. So we're going to times that by 4. That'll be 1.37. We'll call it 1.37. And this will be a positive 1.37 because it is pointing up on the y-axis. So here we go. Okay, so far we've got negative 3.76 R plus 1.37 U. We'll hang on to that 1 second and we'll come back to that later. Okay, now we're going to take care of doing, I'll do this in a different color, 5 and 135 degrees. So I'll do that down here. So 135 degrees will be 90. And then over here, we'll do our little triangle. Then that'd be perfect. There's a 5. And 90, and then 135 degrees, which means this is 45 degrees right here, okay? Which means also that this is 45 degrees as well. So we're going to find our R again and our U. Okay, so we need to go ahead and find the cosine of 45 degrees. So let's clear this out. 45, and we have a cosine, 707. And that's going to be multiplied by 5 this time. And there we go, 3.54 we'll call it. All right, so we have this 3.54, and don't forget that'll be negative 3.54 as R. Okay, and again, let's try 45 degrees, and we will go sine this time. And looky there, and times 5 will be exactly the same thing. If you recall, since they're both 45-degree angles, since this is, the opposite side will be exactly the same. And this will be a plus 3.54 U, all right? Now all that's left for us to do is just to add these two together. So we have a negative 3.76 R and a negative 3.54 R. That'll give us a total of a negative 7.3 R, all right? And the U, positive 1.37 and positive 3.54 will give us a positive, and that'll be 9.91 as U. There we go. Okay, we just added those together. All right. So let's try, go ahead and pause it and try to practice problem A. Okay, if x is the same thing as 3y, then we'll just go ahead and put 3y here, and we can put 3y here. We have two new equations then. 3y plus y is 4y, plus z equals 56. Then we have 3y minus 2y is just 1y, minus 3z equals negative 25. All right, so I'm just going to go ahead and I'll multiply the bottom by 4. So I get a 4 here. I'll have a negative 12 and a negative 100. That's nasty. Negative 12z, negative 100. Okay, then I will subtract this. Subtract all the way across. So z minus negative 12z is the same thing as z plus 12z. 56 minus negative is plus. So z is equal to, and of course I don't expect you guys to know your 13s tables, but there's your z, that's 12. Okay. All right, well, I probably should have tried to find y first. Okay, actually, you know what? I'm gonna try this again, and we're gonna do y instead. So that was a good wasted 2 minutes. All right, here we go. Yeah, x is 3y. Okay, so we'll do our equation. Okay, that's going to be 3y here and then 3y there. So 3y plus y is 4y plus z equals 56. Then we have just regular old y minus 3z equals negative 25. Okay, now let's get rid of the z's then. Okay, I'm going to multiply this by 3, which gives me 3z. Good gravy. And that's going to be 12y, and then 56 times 3. Good gracious. And 3 times, I just lost it. I'm going to do 4y, I said 12y. Okay. All right, well, let's add this. 13y is equal to 143. And if you know your 13s tables, I'm sure you all do, that's going to be 11. So y is 11. All right. So x is 3 times 11, which means x is 33. And then we can pick either one of these you want to. I'll just pick this one because it looks easier to piddle with to figure out to find what z is. So I got 33 plus 11 is 44. 44 plus something is 56, and the z is going to be 12. Ugh, that was a mess, wasn't it? Okay. All right, let's move on to the addition of the two vectors. Okay, first let's figure out negative 2, negative 15. Make sure I have that right. And 510. Okay, so here we go. Let's go 510 first. Okay, so we'll just make this, we know it's going to be over here somewhere. We don't care how accurate we are. We just want this to be a 5. We want to realize that this here is 90 plus what gives you 110? 20, which means this is 70. That's what we're trying to figure out. Okay, so that's going to be your R, and that'll be your U, making sure. Okay, all right. Well, let's figure it out. We got cosine and sine to deal with again. So we have a 70, and we have our cosine. So there she blows. Okay, 0.342. We're going to multiply that by 5, which will give us 1.71. Okay, so we'll call this 1.71, and don't forget that's going to be a negative. Hang on to that. Okay, our sine of 70 is what we want next. So we got 70, and then we have the sine of 70, which is that, and then times 5, which will give us we'll call it 4.7. Okay, so we have this, we've got that, we got 4.7u. Okay, I'll hang on to that for a second. Okay, all right, let's go negative 2 and then negative 15 degrees. Okay, now again, if you're telling the captain, help, help, I'm lost, I'm at negative 15 degrees, and he goes, okay, you know, negative 15 degrees is here. and I'm 2 miles out, but you know, and your captain, or let's say your captain says, I can only go backwards. You know, tell me how to do that backwards. You go, okay, because if you tell him you're negative 15 degrees out, and you tell him to go 2 forward, he will go this way. What you're actually trying to tell him is that you are negative 2. So in other words, his boat cannot go anywhere but backwards too. So if you tell him, okay, I'm negative 15 degrees and negative 2, okay? So he goes, okay, you know, he goes this way. He's facing this way, and he goes, he's pointing at negative 15, right? But then he goes backwards, like that. And you go, thank goodness, because that's where I am. Not at 2, negative 15 degrees, but at negative 2. Our angle here is also 15 degrees. We're going to find our R, we're going to find our U. So let's go and find our R and find our U at 15 degrees. So we have 15 degrees, and our cosine is that. And we'll multiply that by the 2, which gives us 1.93, we'll call it, okay? And that's going to be our negative 1.93, of course, since that's going the wrong way, okay? The U will be positive, so let's go ahead and find the sine of U, which will be this times 2, which is about 0.52, we'll call it. Okay, so here we have 0.52U. Okay, so add these together. We're going to have our R's first. We'll have negative 1.93 plus negative 1.71. That'll give us negative 3.64 R. Okay. And then plus, we'll have 0.52 plus 4.7. That'll give us 5.22U. So that's the same thing again as telling the captain, hey, we're here. What you need to do from your base is to go west 3.64 miles and then go north 5.22 miles and you'll see us. Okay. All right. Well, you guys have a good rest of the day, and we will see y'all next time. Thanks.